Hello and good morning. Let's take a look at today's work here. We're in week 9, so make sure you label that. Today is the last day of February, 22nd, week 9. Okay, anyhow, you're going from the minute hand from 1 to 8. So that's, well, the whole circle is 360 degrees. And you're dividing it into 12 pieces. So let's find out how much each one's worth. So 360 divided by 12, I get 30. So each one of these clicks is 30 degrees. So from here to here is 30. So that's 1, 2, 3, 4, 5, 6, 7 times 30 is going to give you 210 degrees. So to figure out the distance from 1 o'clock all the way to 8 o'clock, you're going to use the 210. So it's going to be 210 degrees over 360 times pi times diameter. And the diameter here is, well, we need to have a radius. So we're going to put, from here to here, we're going to put 5. Okay? So that's going to be 5 times 5, that's going to be 10. And so now you multiply. So 210 times 3.14 times 10 press equals divided by 360. And I get 18.3 inches. And that's it. And that's how you do that. Okay? On this next one right here, find the shaded region. Well, you're going to do the area of the big one minus the area of the small one, and you're going to be left with the outside region here, and that's what they want. Okay, so it's going to be pi radius squared minus pi radius squared because it's area, and here you have 90 degrees, so that's 90 over 360. Okay, same thing here, 90 over 360. All right, pi we know is 3.14. The radius on the big one, we have 10, so that's 10 times 10, so that's going to be 100. And then on this one right here, 4 times 4 is 16. So you're going to multiply these numbers and divide. Same thing here, and then you subtract and you get your answer. Make sure you understand that concept. Okay. Now some of you might be saying, well, what is it? Okay, well let's try it. So 90 times 3.14 times 100 press equals divide by 360. If I did everything right, I get 78.5 minus, this one's going to be 90 times 3.14 times 16 press equals divide by 360. And I get 12.56. And then when you subtract, so minus 78.5, it's going to be a negative, but change it to a positive. The final answer is going to be 65.94 square inches, because it's area. Let's talk about today's work. I'm going to make this a little bit smaller. Put away your bell work on a new sheet of paper. Copy this down. We're going on to 10.3. which is dealing with chords. Now you know chords in music, but we're talking about chords in circles. So let's go over a little bit of definitions here. So a chord has the endpoints on the circle. The diameter is the longest chord. Make sure you know that. This one right here, it says find AB. Well, to find AB, what I would do is split this in half. Okay, so if this angle is 123, we're going to pull out this little bitty triangle like this. We're going to put a 5 here. We're going to put a 90 degrees, and we're going to split that 123 in half. So 123 divided by 2 is going to be 61.5 degrees. Okay, once you have that, you can figure out this piece, and then you double it to get the whole thing, which is what they want. So we're going after that little piece, and then we're going to double it. So we're going to use trig. So put a dot right there. This is opposite over hypotenuse. So that's going to be the sine of 61.5 is equal to opposite over hypotenuse. So that's going to be 5 times the sine of 61.5, and then you want to double it. So let's try that. So 61.5 sine times 5, and then times 2. I get 8.8. So from here to here is 8.8. Make sure you understand what I did. I split the triangle in half, I did trig, and bam, I got my answer. So trig is not going away. All right, copy this down as well, and then I'll give you your work. All right, the theorem says that if two chords are equal, then the distances are equal. So let's talk about that. So what does that mean? So draw a circle and make a chord here and make another chord here. And let's say this one is 8, and let's say this one is 8. So if the two chords are congruent, well, they are, then the distances are equal. So this distance from here to here will be the same as this distance from here to here. So if this was 8, this one would be 8. Okay? And the converse is true right here. If the distances are equal, so if this distance is equal to that distance, let's say 9, then this chord is equal to that chord. Okay? The converse. Converse means switch. So let's look here. Distance bisects the chord. Okay, so that's another thing you got to know. So since this distance is equal to that distance, then this is 2. The chords are equal, so all of these are 2. Okay? Remember, if the distances are equal, the chords are equal. All right, your assignment's right here. Let's turn our attention now to MCR. And those of you, again, in geometry, make sure you finish that savants. Greatest common factor, you got to factor stuff out. So this one is going to be 2 times 3, and then R, 5 of them. This one is going to be 2 times 3, and then 4 R's. So what's in common? Well, they have a 2, so you take a 2 out. They have a 3, so you take a 3 out. They have 4 of these, along with 4 of those, so you're going to take 4 of those out. This is your greatest common factor. Since the first one is a negative, they want you to pull a negative out as well. So what's left here is an R, and then this one becomes a positive when you take a negative out. And then this one, there's nothing left, so you put a 1, and that's how you factor. This is the greatest common factor, which is what they want you to do today's worksheet, but I want all of it. Okay, so today's worksheet, I want you to do the greatest common factor, but I also want you to write it in factored form. And we'll work one in class. All right, have a good morning, and I'll see you there.